Good morning. Today I'm going to try running that the mold that makes the carburetor holders for the Honda 360 and KZ 440, although I have it set to make parts for a 440 because that's the one I'm low on stock. That's the one I need inventory on. So I'm going to make 440, KZ 440, that's a Kawasaki. And so I can start out with my process sheet, because sometimes I don't remember what it takes to run it, and this is sometimes a help to at least get you started. It's not a hard and fast rule, but the process sheet tells you about what to start out at. Okay, I see my weight is supposed to be 170 grams, and the prep size is supposed to be 3 1/4 by 3 1/4, and it takes 2 pieces that size. So I also want to check my temperature, which is 320 on both platens, is what I was running it at. So I'll set the temperature up here to 320 on both. I was running it on an even temperature. Now, after I do that, okay, like before, to get started, we take our safe switch and we turn the power on to the controls. Now the press will move. You'll see the press is starting to come down. And get our hot mill gloves on here. Take our mold out. Don't have to wait for it to come all the way open. Now, we have to take the mold clear apart rather than just put rubber in there, because we have inserts to put in here. So I want to do that first. So, okay, these are the 2 smaller ones, and always I hold them by the edges like that. Drop them down on those pins. And then the bigger inserts go here. Now you'll notice, because the mold's hot like that, I don't want to touch it with my fingers because that'll give me a burn. And if it sits there long enough, you'll notice that black paint on there start to bubble up and turn soft. It's some sort of a rubber that tends to make it vulcanize to steel. So here's my cavity. I'm going to put that on. Over top, make sure it's down all the way and that everything's on the pins right, because you can sure mess up the mold if you don't get that insert in there right. And like I say, these molds are what's making you the money, so I don't want to mess those up. This looks okay on here. There's no little scraps of rubber or uncured rubber. You want to watch for that. Put that against my key. Right there. And then I'll get this rubber put in there. If I had any extra little pieces, I put them in the side. Now you can see it's pretty close to the top edge of this thing. So this pot ain't deep enough to really put, you know, you got to be real careful that when you put this on there that it's going to go down in the pot. Put this in the press and start a cycle. And that's pretty much all there is to it. Set your time, your temperatures, and be sure the pressure's turned back on the press when you're using these aluminum molds. I have it set to the minimum pressure. I don't want to use 80 tons on an aluminum mold. And that's all there is to it, and we'll come back when it's time to get them out. Okay, press is popped open. We've cured them in there for 14 minutes, which these are fairly thin. Some of the bigger sockets I do with more rubber on, I got to cure a lot longer than that, but you don't want to push it when you're using inserts. You want to give it time to bond in there. It takes a while for that glue, that paint we put on the inserts to set up. So now we're ready to take these out. I always check on here, make sure there's no stuck rubber or snibbles or anything you can blow with it too. My process sheet says that I break the sprues first, so I'll pry up on this. Pry those two apart. Then should be able to get those out of there. I might need a little bit different shaped pry bar, something a little wider maybe these here. I'll raise her up a little more so that I can get this top piece off. Now there you see the parts are in the cavity right there. You can see the sprues where the rubber came in, and all I got to do is get this piece of rubber out of there. For that, I sometimes just use a little pair of needle nose pliers if I can get a hold of it, like that. Kind of pull it out. You want to be kind of careful because you see all those sprues on there. You don't want to break off any rubber in the mold. And to check the screw holes to make sure that I'm not breaking anything, you also see some snibbles of rubber in here. That you can go around with your glove and just knock them out. But hold it up to a light, and that way I can check to make sure all the screws are open and there's no broken piece of rubber in there. And there isn't. You don't want to blow it too much because you don't want to cool this off. You're trying to keep your mold hot and load it as fast as you can. You have to remember, don't make no money while the press is just sitting there open doing nothing. So next I have to get the cavity off of here. Those pry bars just aren't quite wide enough. This is maybe, I don't know, 1.25 wide or something like that, 1.5/16. And you can use that to make sure it's loose. Alright, now there's your parts. You can see, if you rub this a little bit, you can see the parts in the cavity right there. But they're kind of stuck in there. That's because that metal plate's in there and there's rubber between the metal plate and the cavity, and the rubber's hot. And when the rubber gets hot, it's going to swell. Puts a lot of pressure on something. It's just too much pressure for me to eject out of there by pushing with my thumbs. Besides, you'll get sore thumbs doing that. So this is where I use this block right here. And I set the mold in there. Get me a piece of plastic like this, put in there. Boom. Now you'll see there's my part sitting in here, you see? And that's all there is to it. The smaller ones, the same way. I got a different piece of plastic, it's a little bit different size, but I can put that in there. And you could probably use a piece of wood for this too, just something that's not going to damage the rubber, you know. This is just some old stuff was laying around under the lathe I'm using. So. But anything would work for this. And anyways, that's how you get the parts out. You'll see there's our card sockets there. And they look pretty good. Certainly good enough. And they do seem to have filled out. You know, you always check to make sure you don't have any places that didn't get full of rubber. You can always add a little bit more rubber. If you got enough room in that pot, you can always put more rubber in there. So now, all I got to do is put new inserts in here. I put a sliver of cured rubber will hold that mold open, and I don't want any slivers of rubber in there, and I also don't want it mixing in here with these parts, so I try to get all that off. And these parts I set over here on the table. I'll look at these later after I get my next heat started. And now I get a couple more of these things in here. Put the big ones on here and the small ones on here. Put this slot against the key. Make sure she's all the way down on here. Looks like it's sitting fine. You never know, they might give you too big an insert, or you put something together wrong and not see it. It always pays to make sure that your mold is together, not sitting open. Something's holding it open, why it's going to get crushed when you put it in that press. And now we'll put more rubber in there. This is one of the preps I had where I had to make some extra pieces, so I can lay them in along the sides here to make sure I got enough rubber in there, you see. And of course, when it's hot, you can push down on it a little bit to make sure it's starting. Now this pot is really, really full. So here, I put it in there like that, put it in the press, and we're ready to start a cycle. That's all there is to it. Okay, just a little note on flash on these carburetor sockets. I don't know if you can see or not, but there's like a skin of rubber inside here. I just grab that with my fingers and pull that out. That's made from the rind cavity, and makes it pretty easy to dislodge that flash. And the flash always comes off easier when the parts are hot than when they're cooled off. And so when they're still a little bit warm and you can handle them, you got to be a little more careful with these because they got a metal insert in here. Now these here are just about stone cold. And then as far as the edges go to deflash them, I just kind of go around them with this. This is one of those things for peeling oranges or something. But it's a nice, it's not a very sharp knife. It doesn't need to be real sharp. Just something to kind of help you get that flash off the edge. Makes them look a little bit nicer. It has nothing to do with the way the part works. The flash usually is just a cosmetic thing, you know. The other thing you can do if you have thick flash on something, these little surgical scissors with a little curve in them, they come in pretty handy for like trimming off flash if you want to do that. So anyways, that's pretty much done right there, and it will be ready to go over to the drill press. I usually clean out these holes, pass a drill through there to make sure that those holes are opened up and they don't have any trouble getting their bolts in there, because a lot of guys using these, they don't have a drill press or any way to clean something up very well. So that'll be the next step. Anyways, that's about all there is to it. Okay, now we're going to try to get some of the rubber out of these holes, because I usually make the pins a bit undersized, because the metal plates, if you make the core pin that cores out these holes the same size as a hole, you'll find you have trouble getting the part out of the mold. So I make the core pins undersized in order to help me get the part out of the mold, because the molds are aluminum, the plate's steel, everything expands and contracts different, and therefore making them loose is better than making them tight. Anything about rubber molding, you get too much precision, it's not a good idea. It's not like plastic injection molding or something. This is a lot less precision in this. So what I have to do now is clean the rubber out of those holes. I've already showed you how I get the flash off the edges around here, which you can even do with your thumbnail or pull it off with your fingers. Any place you got, you know, flash, it's just real thin stuff. Get rid of that, and now we're going to clean out these holes on these parts. Now this is a 6mm bolt goes in there, so a 1/4 inch drill is what I'm using to clean them out with, which seems to be plenty big enough. I mean, I might not be getting all the rubber out of there. I could go to the next size bigger drill, I suppose, but I just use 1/4 inch. That's close enough. You could even use a metric size drill. Make sure you got a metric size hole in there. But that's all there is to doing that. So if you got a drill press with a small hole or a narrow slot, if you didn't have slots like this, if all you had was a big hole like that in your drill press, this is a real old drill press. If you had just a metal plate, you could C-clamp on here with a small hole drilled in it. That would work too for a backing plate to drill through. You know, I could put another sub plate, just lay a plate of steel on here or something with a hole in the same size as a drill even, and make the drill go down in there. You put the drill through the slot to line everything up, and that's all there is to it. it would make a nice hole for you.